For more information, refer to the Project 2B specifications. Our aim is to write a program for our washing machine. Our machine has a level sensor, and our PLC will see 0 to 10,000 counts for 0 to 100%. It has a temperature sensor, and our PLC will see 0 to 10,000 counts for 0 to 100 degrees C. It has an overbalance sensor that will operate if the machine overbalances, and the PLC program will have to latch. It will pause the operation. Lifting the lid and closing the lid will reset the overbalance, and the machine will continue the cycle. If the lid is lifted, then the operation will pause whilst the lid is up and continue when the lid is closed. The PLC will control solenoids that operate the functions of the machines. In the main program, we have the start-stop controls, plus the calls to the subroutines. When the start button is pressed, the variable cycle is turned on. It will stay on until the machine completes or the stop button is pushed. The fill subroutine is called. We want to run the subroutine until the machine is full, and then we don't want the fill to have an effect until the machine is restarted. We can turn on the variable fill fin when the fill cycle is complete. You can write a sentence. Run the fill subroutine if cycle is on and fill fin is not on. When the fill is complete, run the heat cycle. When the heat is complete, turn on the heat fin variable. Once again, we write a sentence. Run the heat subroutine if cycle is on and fill fin is on and heat fin is not on. When the heat is complete, run the agitator cycle. The agitator cycle basically consists of the program for turning two outputs on and off in a fixed time cycle that was developed in the previous two videos. Refer to the two solutions suggested in the previous video regarding using counters in subroutines. When the agitator is finished, turn on the variable ag_fin. Run the soak cycle. With the soak cycle, the machine will wait for 15 seconds. It is suggested that the soak cycle is put in the main program because if it is in a subroutine, it will be difficult to switch the timer off. Turn on the variable soak fin. Run the final spin subroutine, and when the cycle is complete, turn on the variable spin fin. Run the finish cycle, in which the machine will wait for 10 seconds and then stop the machine, turning off the cycle variable and clearing the variables, so the machine is ready to start again. If the stop button is pressed at any time, then all the outputs and indicators should go off and the machine should be ready to start again. When the program is first run, then all outputs and indicators should go off and the machine should be ready to start again. We're going to look at the words in the program specification and then change them into a program. Start with the output and put what valve at the bottom of the page. The program specification says fill the machine to 60%, so if the level is below 60%, turn on the water valve. When the level gets to 60%, turn off the water. The program specification says to wait 5 seconds and then fill to 100%. So we can use turning off the water variable to start a 5-second timer and then turn on the variable delay. Delay is used to turn the output what valve on again. We will test the level, and when it is greater than or equal to 100%, then turn on the variable fill fin. Fill fin will turn off the output what valve. Finally, it says to turn on the fill cycle light, which we can add to the bottom. Fill fin can turn off the fill cycle light. What would happen if the line with the greater than or equal to and the fill fin coil was below the outputs what valve and fill cycle? The top-down design approach suggests that when you have a large project that you should divide it up into a series of smaller jobs that can be fitted together into the final project. This project is best done by dividing it up into smaller items. Start with the main program, then complete the fill subroutine, and then complete the clear. That way you can test your project as you develop the project. Once each section is done, you can move to the next section. Each small section can be debugged and finalized. By doing the clear as you go, you can change your program, reset it, and test it by doing a build changes, which transfers the program and goes back into run mode. Then press the stop button to reset your program. This will save some time. Use the Project 2B operating screen to test your program. The two sliders are to simulate the temperature and level sensors, so we will manually slide these up and down. The green lights are the solenoids for the machine functions. The yellow lights are the indicators to show which cycle the machine is in. It is very important to save a copy of your program many times and with a different name. Use version numbers. In the history of computing, millions of hours of work has been lost because a computer fails and the work wasn't backed up.